All right, we're going to continue on in Module 1 and move to Lesson 3. This lesson is going to talk about reflections. So previously we've talked about the broad category of transformations. Transformations are ways that we can move shapes in the coordinate plane. We talked in our previous lesson about a translation in which we slide an image, and today we're talking about a reflection. A reflection is a transformation of a figure that flips the figure across a given line. This given line is called the line of reflection. Right, so the key things here is with a reflection, the word that we're looking at is it is a flip of the figure. And in the case of our lesson in pre-algebra, our line of reflection is either going to be the x-axis or the y-axis. All right, so whenever you see the word flip, think reflection. All right, what possibly comes to your mind when you're thinking of reflection? Maybe looking into a mirror. All right, so the object is flipped from the way that you would originally see it, and the line of reflection is either going to be the x-axis or the y-axis. Remember, our x-axis is the horizontal axis, and the y-axis is the vertical axis. All right, so in our workbooks, we're on page 23, and we're going to go through an example here. How can you reflect a figure over the x-axis or the y-axis? Reflect the image shown over the x-axis. Remember to keep each point of the image the same distance away from the x-axis as the corresponding pre-image point. For instance, point C is 12 units from the x-axis. All right, so if we zoom in, we can see that point C is 12 above the x-axis. So the C prime, which is our image, must be 12 units from the x-axis. So the only way that that can occur is to go down into quadrant 4. All right, so we want to keep it the same distance away. So this coordinate right here for C is 312. In order to reflect it over the x-axis, we're going to keep the x the same and change our y to a -12. All right, so we'll go ahead and plot that point at 3, -12 for C, which is right here. All right, and that will be C prime. All right, they already did A for us, so following that same pattern, the x stays the same whenever you are reflecting over the x-axis. The y is what changes. So let's go ahead and repeat that pattern all the way through. Again, our x will stay the same, and our y will flip. It'll be the opposite. All right, and we'll do that for E as well. 9 and -8. All right, so let's go ahead and plot those points. So A prime should be at 3, -2. So 3, -2, that's A prime. Then B should be at 3, -8. So we'll plot that. 3 down to -8. That's B prime. We already did C prime. Let's find E prime is, or D prime is at 9, -12. So let's do that. 9, -12 will be down here. All right, and that is D prime. And then last, E prime is at 9, -8. 9, -8, E prime. And if we fill in these lines, we now have a reflection. All right, it should be a mirror image. All of these points should be equally spaced away from the x-axis. So the distance away from the x-axis should be the same for the image to the pre-image. All right. Is the pre-image upright, or the pre-image is upright? So is the image also upright, or has it changed? All right. Well, we can see that the image has changed. All right, the image has changed. It is no longer faced upright. It is now in the opposite direction. All right. All of the side lengths are going to continue to be the same. All right, we'll see that if we look at the distance of the line segment AC. All right, so we're looking at this segment right here, AC, in the pre-image. It goes from 2 to 12, so that line segment is 10 units. And then this goes from -2 to -12. That is also 10 units. All right, so both line segments are 10 units. And as is the case with all of the transformations that we're talking about, all right, the length of all of the line segments will stay the same. And all the angle measures will stay exactly the same. The only thing that might change is its position or its orientation, all right, which is the case here. The original letter F faces to the right. Reflect the original image over the y-axis, all right? So we noticed that anytime that we were reflecting over the x-axis, the x-coordinate stayed the same and the y became its opposite. If we look at our pattern for point C, we'll notice that when you reflect over the y-axis, all right, what changed? Well, the x-coordinate is what changes. So we're going to take the opposite of our x-coordinates, and our y-coordinates will stay the same for all of these. So let's follow that pattern and write out our coordinates for the image after we reflect it over the y-axis. So if we look for A, we'll see that we need to take the opposite of the x and the y will remain the same. We're going to take the opposite of the x and the y will remain the same. For D, same thing. Opposite of the x, y stays the same. And then last E, opposite of the x, y stays the same. So we have our coordinates, and we can go ahead and plot these points on our coordinate plane. All right, so -3, 2. All right, that is A prime. -3, 8. That's going to be B prime. And then C prime, -3, 12. C prime. D is -9, 12. So -9, 12. D prime. And E is -9, 8. -9, 8, which is right here. E prime. All right, so we'll fill that in. And we'll say that the letter F now faces to the left in the image. All right, so pre-image faces right, and image faces left. All right, so on the turn and talk, if you were in class, we would be discussing the distances of the DE segments, and we would notice that those distances remain the same. All right, so the distance between D and E is 4 units, and it is also 4 units here as well. The term that we use when we say things stay the same, we want to get used to using the word congruence. So build up that mathematical vocabulary. All right, let's go ahead and look at our next example. This is on page 24. On a piece of graph paper, draw a parallelogram in the third quadrant of the coordinate plane as shown. All right, so this is quadrant 3, where the parallelogram is drawn. We need to reflect the pre-image over the x-axis and describe the location of the image after the reflection. All right, so our pre-image, they list out all of our points for us in part C. When we reflect it over the x, we need to remember that it's not the x value that's going to change, it will be the y value that will change. So all of our x values will remain the same, and we'll take the opposite y value. So let's go ahead and do that. X stays the same, we take the opposite of the y. X stays the same, take the opposite of the y. All right, so again, x stays the same, opposite of the y. All right, so let's go ahead and plot that point and see where its location is now. So if I go to -10, 5, all right, -10 out here, 5, be about right there. And that's going to be A prime. B prime is going to be at -7, 2. C prime is going to be at -3, 1. D prime is at -6, 4, which is right here. All right, so we can go ahead and draw that figure out. And if we notice, we are now located in quadrant 2. All right, we are now located in quadrant 2. So we'll list that for A. The image is positioned in quadrant 2. All right, reflect the pre-image over the y-axis. All right, so this time when we reflect over the y-axis, we're going to take the opposite of the x-coordinate. All right, so we'll take the opposite of the x, and the y will stay the same. So let's go ahead and do that. Opposite of 10 is opposite of -10 is +10, and then our y-coordinate will stay the same. The opposite of -7 is +7, and then the y-coordinate will stay the same. Opposite of -3 is +3. Y-coordinate stays the same. And the opposite of -6 is +6. And again, the y-coordinate will stay the same. Let's go ahead and plot those points. So 10, -5 would be right here. And that's going to be A with 2 primes. All right. And then B will be at 7, -2. B with 2 primes. C is going to be at 3, -1. 3, -1. C prime. And then D is going to be at 6, -4. 6, -4. D, 2 primes. We'll close it all in. And we can see that this is now in quadrant 4. All right. So the image is positioned in quadrant 4. All right. Now for our check understanding, we are going to look at the 2 sets of quadrants and determine what line the triangle has been reflected over. All right, so this is what we're trying to figure out. Which line has it been reflected? So if we notice, the x values stay the same. It is the y values that are changing. So which one does that follow? If I look here, it appears that it is following the x-axis. So our line of reflection, the line of reflection is the x-axis because it's the y values that are changing. All right. The coordinates of the vertices of a square are listed here. All right, so we have the 4 vertices because there are 4 sides to a square. The square is reflected over the y-axis. All right, so if it's reflected over the y-axis, we need to write the new coordinates of the image after this reflection. So we know that all of the x values need to change and the y values need to stay the same. So instead of -10, our first coordinate will be 10 and then -2. The opposite of -5 would be 5, and the y value will stay the same. We'll do it again for the next one. Opposite of -5 is 5, -7, and then finally 10, -7. Those would be our 4 coordinates. All right. In your own words, describe the meaning of a reflection. All right. So a reflection can flip an image over a given point. All right, over a given point or over a line of reflection, whatever's going to allow you to remember what a reflection is. All right, basically we need to remember flip. All right, and it's going to go over either the x or the y axis. All right, so the test prep will give you a good indication of how well you understand the lesson. All right, so you should work on the 3 test prep questions, 5, 6, and 7. And If you're able to do those problems, then you should feel confident that you understood the lesson material. If you still have questions, you can post a question in the comments under the video, and I'll do my best to try and answer any of those questions. That's all for this lesson.